Imagine that tonight, every telescope on Earth suddenly detects an unmistakable signal from another intelligent civilization. Not a random burst of radio noise, not a strange star, an actual message, proof that somewhere in the darkness another species is looking back across the cosmos. It would instantly become the greatest discovery in human history. Religion, science, philosophy, and our entire understanding of existence would change overnight. Despite decades of searching and a universe so unimaginably vast that our minds strush to comprehend it, we still haven't found a single piece of undeniable evidence that anyone else is out there. The question isn't just whether aliens exist anymore. The real mystery is far more unsettling. If the universe should be full of life, then where is everybody? To appreciate just how strange this mystery is, we first need to understand the sheer scale of the universe. The observable universe stretches roughly 93 billion light-years across. Inside that incomprehensible volume exist hundreds of billions of galaxies. And over the last few decades, astronomers have discovered something remarkable. Planets aren't rare exceptions orbiting a few lucky stars. They appear of those planets sit inside what scientists call the habitable zone, where temperatures may allow liquid water to exist. When you multiply these numbers together, the result is staggering. There could be trillions upon trillions of potentially habitable worlds scattered throughout the universe. Common sense suggests that intelligent civilizations shouldn't be extraordinary. They should be everywhere. Yet when we point our telescopes toward the heavens, we find something unexpected: silence. No unmistakable radio conversations filling the galaxy. Just quiet. And that's exactly what makes this mystery so fascinating. Because statistically, the numbers strongly suggest that life should exist in abundance. Reality, however, tells a completely different story. Before we go any further, I want to hear your opinion. Based on everything humanity has discovered so far, do you believe intelligent alien civilizations already exist somewhere in the universe? Or do you think Earth might actually be the only place intelligent life has ever evolved? Let me know your answer in the comments before we continue, because by the end of this documentary, you may find yourself changing your mind completely. Now, it's important to narrow our search. Even if intelligent civilizations exist in distant galaxies, chances are we'll never know. The universe itself is expanding, and that expansion is accelerating. Entire galaxies are moving away from us so rapidly we could realistically imagine would ever catch them. Even traveling at speeds far beyond anything humanity has achieved, journeys between galaxies would require billions of years. By the time travelers arrived, the destination would have changed dramatically, or become forever unreachable. Everything beyond our immediate galactic neighborhood is permanently isolated from us. So instead of searching the entire universe, let's focus on a much smaller place. Our own cosmic home. That home is the Milky Way galaxy. Although it seems tiny compared with the observable universe, the Milky Way alone is almost impossible to comprehend. It spans roughly 100,000 light-years from one side to the other, and contains as many as 400 billion stars. If you counted one star every second without stopping to eat, sleep, or rest, it would take far longer than many generations to finish. Somewhere among those hundreds of billions of stars are around 20 billion that closely resemble our own sun. Even more astonishing, current estimates suggest that many of those stars host rocky, Earth-sized planets orbiting within the habitable zone, where conditions could potentially support liquid water and perhaps life itself. Let's be incredibly conservative with our assumptions. Imagine that only 1 out of every 1,000 potentially habitable planets actually develops even the simplest form of life. That would still leave an enormous number of living worlds inside our galaxy alone. And if only a tiny fraction of those worlds eventually produced intelligent civilizations capable of developing technology, then the Milky Way should already be filled with countless societies spread across millions of years of history. The numbers refuse to cooperate with what we actually observe. Every calculation keeps pointing toward the same conclusion. We shouldn't be alone. The timeline of our galaxy makes the mystery even deeper. The Milky Way formed more than 13 billion years ago, while Earth is only about 4.5 billion years old. During the galaxy's violent youth, constant supernova explosions and intense radiation made life extremely difficult. But after the first 1 billion or 2 years, stable stars and potentially habitable planets began forming across the galaxy. That means other civilizations, if they exist, could have started their journey billions of years before humanity even appeared. Imagine a civilization that gained just a 1 billion year head start over us. Compared to them, our entire technological history, from the invention of the wheel to modern space exploration, would occupy less than the blink of an eye. If even one such civilization survived and continued advancing, the Milky Way today should look dramatically different. And yet, it doesn't. If civilizations really can survive long enough to keep advancing, then the next question becomes unavoidable. How powerful could they eventually become? To answer that, astronomers use a framework known as the Kardashev scale, a way of measuring civilizations not by their population or military strength, but by the amount of energy they can control. It's a simple idea with extraordinary implications. The more energy a civilization can harness, the more capable it becomes of transforming its world, exploring space, and reshaping its future. Suddenly, the search for aliens is no longer about little green creatures hiding on distant planets. It's about civilizations so advanced that their engineering projects might be visible across the galaxy itself. A Type I civilization is one that has learned to utilize nearly all the energy available on its home planet. It can control its climate, efficiently harvest renewable resources, and command technologies far beyond anything we possess today. Humanity hasn't reached that level yet. In fact, according to most estimates, we're still below it, roughly 3/4 of the way there. Assuming we avoid major setbacks and continue advancing, we may eventually become a true planetary civilization over the next few centuries. But that's only the first step. A Type II civilization takes an even more astonishing leap by capturing the energy output of its entire star. Concepts such as the famous Dyson sphere, or more realistically, a vast swarm of millions of solar collectors orbiting a star, illustrate how this might be achieved. Such structures sound like pure science fiction today, but the laws of physics don't forbid them. Given enough time, resources, and engineering knowledge, they remain theoretically possible. Then comes Type III. A civilization that has expanded beyond a single solar system to harness the energy of an entire galaxy. Imagine billions of star systems connected through unimaginable technologies, each contributing to a civilization that spans 100,000 light years. To us, such beings would appear almost indistinguishable from gods. They wouldn't simply travel between stars and build structures on scales we can barely visualize. If a civilization like this existed anywhere inside the Milky Way, its influence shouldn't be subtle. We would expect to detect enormous engineering projects, unusual energy signatures, or entire regions of space behaving differently from what nature alone would produce. This leads to one of the most important ideas behind the Fermi Paradox. Even without faster-than-light travel, spreading across the Milky Way may not actually take very long on cosmic timescales. Imagine a civilization building massive generation ships, spacecraft capable of supporting entire communities for centuries. They launch toward the nearest star, establish a colony, and after several generations, that colony launches new expeditions. Like ripples expanding across a pond, each new settlement creates countless more. The process is slow when viewed from a human perspective, but the galaxy itself is unimaginably old. Computer models suggest that a determined civilization could gradually colonize the entire Milky Way in just a few million years. That may sound like forever to us, but compared with a galaxy over 13 billion years old, it's barely a moment. Now consider the implications. If intelligent civilizations have had billions of years longer than humanity to evolve, then countless opportunities have existed for at least one of them to begin this process. Even if technological civilizations were incredibly rare, still have been explored, settled, or visibly transformed many times over. Instead, our telescopes reveal stars behaving exactly as expected. We don't see giant artificial megastructures harvesting stellar energy. We don't detect unmistakable interstellar traffic. We don't receive obvious transmissions from ancient galactic empires. Everywhere we look, nature appears to be running the show. And that's the heart of the mystery. The mathematics suggest one answer. Reality insists on another. This contradiction is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked a deceptively simple question whether alien life is possible. It asks why, given everything we know about the universe, we haven't encountered any convincing evidence of advanced civilizations. Every new exoplanet discovered seems to strengthen the expectation that life should be common. Yet every year of silence makes the paradox even harder to ignore. To explain this silence, scientists have proposed one of the most unsettling concepts in modern science: the Great Filter. Think of it as an almost impossible obstacle that prevents most civilizations from ever becoming galaxy-spanning societies. Somewhere along the long chain from lifeless chemistry to an advanced interstellar civilization, there may exist a barrier so difficult that nearly every attempt at intelligent life fails. The terrifying part is that we don't know where this filter is located. It could already be behind us, or it could still be waiting in our future. Suppose the Great Filter lies in humanity's distant past. Perhaps the leap from simple molecules to the first living cells is vastly more difficult than we currently understand. Maybe the emergence of complex multicellular organisms is an event so extraordinarily rare that it has happened only a handful of times in the history of the universe. Consider Earth's own story. For billions of years, life consisted only of microscopic organisms before complex animals finally appeared. Perhaps countless habitable planets remain forever covered only by oceans of bacteria, never producing forests, animals, civilizations, or anyone capable of looking up at the stars. If that's true, then humanity may have already overcome the rarest and most improbable steps in cosmic evolution. Instead of arriving late to a crowded universe, we might actually be among the first intelligent civilizations ever to exist. At first, that possibility sounds comforting. It means the silence surrounding us isn't a warning. It's simply the result of extraordinary rarity. But another possibility is far more disturbing. What if the Great Filter doesn't lie behind us at all? What if every civilization eventually reaches a point it cannot survive? A stage where its own intelligence, technology, or ambition becomes the very thing that leads to its extinction. And if that's true, then the silence filling the galaxy may not be empty space at. It may be the echo of civilizations that reached the same crossroads humanity is approaching today, and never made it beyond. If the Great Filter is still ahead of us, then the silence surrounding Earth takes on a completely different meaning. Instead of asking why we haven't found anyone else, we may eventually begin asking why nobody ever survived long enough to answer. Somewhere in the future, there could be a threshold that almost every intelligent civilization reaches, a moment where technological progress accelerates faster than wisdom, where incredible power becomes easier to create than it is to control. History has already shown that every major breakthrough brings enormous benefits alongside equally enormous risks. Fire gave humanity warmth, but also destruction. Artificial intelligence promises extraordinary progress. Perhaps every civilization eventually invents something that it simply cannot manage responsibly, and that single mistake becomes the end of millions of years of evolution. Of course, self-destruction isn't the only possibility. The universe itself is filled with dangers that care nothing about intelligence. Nearby supernova explosions, gamma-ray bursts powerful enough to sterilize entire planets, rogue black holes, unstable death of a civilization's home star all represent challenges that must eventually be overcome. Reaching another star system before disaster strikes may not simply be an ambitious dream. It may be the only long-term strategy for survival. If civilizations repeatedly fail to escape their homeworlds before catastrophe arrives, then perhaps the galaxy remains quiet not because life never begins, but because it rarely lasts long enough to spread. Some ideas become even more unsettling. Imagine that somewhere in the distant past, one civilization did survive, perhaps billions of years until it reached a level of technology we can barely imagine. Such a civilization wouldn't necessarily announce its existence with giant monuments or constant radio broadcasts. It might have learned that remaining invisible is the safest strategy. Perhaps young civilizations like ours are quietly observed rather than contacted, where developing civilizations are deliberately left alone until they reach a certain level of maturity. If that's true, then our silence isn't evidence that nobody is there. It may simply mean we haven't reached the point where anyone chooses to respond. Another possibility is even darker. Imagine an ancient civilization that views every emerging technological species as a potential future threat. From that perspective, waiting would be dangerous. Eliminating young civilizations before they become powerful competitors would be the safest strategy. But in an unpredictable universe, survival might encourage ruthless caution. Every new civilization that begins broadcasts itself to something far older and far more capable. Thankfully, there is absolutely no evidence that such a civilization exists. It remains speculation, one of many attempts to explain a mystery for which we still have no definitive answer. But it demonstrates just how many possibilities emerge once we seriously ask why the universe appears so quiet. If you enjoyed exploring one of the most fascinating ideas in modern physics, make sure to subscribe and turn on notifications so you don't miss our next journey into the deepest mysteries of the universe.